One of the applications of the double angle formulas is the derivation of the power reduction identities. So what are the power reduction identities? Cosine squared alpha is equal to 1 plus cosine 2 alpha over 2, and sine squared alpha is 1 minus cosine 2 alpha over 2. Now, why are they called the power reduction identities? Well, you see you have a cosine squared here, and it turns into a cosine to the first. There's kind of this conservation of complexity. Cosine squared is more complicated than cosine to the first, but it's not just a regular cosine because we have to change the angle on the inside here. Now, why might we want to do that? It turns out that for some mathematical purposes, a cosine squared is more complicated to work with than a cosine to the first, even if you have to change the angle here. And so this turns out to be one of the reasons why we like these formulas. We can reduce the power of the cosine to make it so that we have maybe a more complicated angle, but we don't have powers of the cosine terms. So where does this come from? Well, the big hint is the cosine 2 alpha term. Cosine of 2 alpha. We have our formulas. So we have one of them that says that this is 2 cosine squared alpha minus 1. And the other one says that this is 1 minus 2 sine squared alpha. And your intuition is probably starting to kick in. All we need to do is take these equations and solve for either cosine squared or sine squared. Let's focus on this left-hand side first. We need to isolate the cosine squared terms. We're going to add 1 to both sides. So 1 plus cosine of 2 alpha is equal to 2 cosine squared alpha. And then divide both sides by 2. 1 plus cosine 2 alpha all over 2 is equal to cosine squared alpha. And pretty much the exact same thing happens on the other side. So if this is set equal to cosine 2 alpha, and we want to isolate the sine squared, we're going to subtract 1 from both sides. So negative 2 sine squared alpha is equal to negative 1 plus cosine 2 alpha. We're going to divide by negative 2 to get sine squared alpha is equal to, let's see, we'll distribute the negative sign, so it turns into 1 minus cosine 2 alpha all over 2. And so this is the derivation of the power reduction identities. So here's an application of the power reduction formulas. Write cosine squared theta, sine squared theta in terms of cosine functions to the first power. So let's take a look at this. Now the first thing is clearly that we're going to use the power reduction formulas. So we have one for cosine squared and one for sine squared. So we can plug that in right away. 1 plus cosine 2 theta all over 2 times 1 minus cosine 2 theta all over 2. Now you might look at this and say, okay, well, cosines are all to the first power, so we're done, except that we have a product here that we need to multiply out, and you'll see what happens. So in the denominator, 2 times 2 is 4. In the numerator, we have 1 plus something times 1 minus something. That leads to a difference of squareds. So 1 minus cosine squared 2 theta. And now here we can see that there is in fact another power of cosine that's not 1, and so we have to simplify this further. What is that going to look like? Well, what we're going to have to do is we're going to have to make this substitution again. Pay close attention to what's inside the cosine squared function. Cosine squared alpha, cosine squared 2 theta. So when we end up here, cosine of 2 alpha, that's going to be cosine of 2 times 2 theta, or cosine of 4 theta. So we need to be very careful with that because that's something that's very easy to mess up if you're going quickly. So here we go. 1 plus cosine of 4 theta all over 2. Okay, once again, fractions inside of fractions, we have a bunch of simplification to do. What can we do here? Well, again, you can multiply by the reciprocal of the denominator. In this case, we only have one fraction term right here, and so I think it's simpler to multiply top and bottom by 2, and that will clear out the fraction inside of fraction piece. When you do this, you do need to be careful. You do need to make sure you distribute. So, denominator first, because that part's pretty easy. What happens if we distribute? 2 times 1 is 2. Minus. Now the 2's cancel out, so we have minus parentheses 1 plus cosine of 4 theta. A little bit of simplification here. 2 minus, well, the minus sign distributes, so 2 minus 1 is 1. And then the minus sign distributes minus cosine of 4 theta all over 8. And so this is an application of the power reduction formulas.